All right, if you move a mass vertically from point A to point B, the potential changes from -65 to -34. Okay, so this is less negative. This is more negative. So doesn't this guy have to be below, right? If A is this. So this is A. This is B. Right, I think A is here, B is there, right? I feel like that. Let's write it. Let's draw it. -65.0 joules per kilogram. It just means that we're below some arbitrary point that somebody has made 0. Negative numbers confuse me. All right, kilograms. Okay, and a distance of 17 meters. Okay, so this is, let's see, from A to B. All right, so we are becoming more positive, aren't we? And that's 17 meters. Okay, so let's see. Okay, so what is the gravitational field strength? Ooh, I can do that. G is equal to the opposite of the change in gravitational potential divided by the distance that you moved. Okay, so that is the opposite. The change in potential is positive something, I believe, isn't it? Because we go from this to this. So 65 minus 34. 31. It's positive. It gets positive by 31, right? Joules per kilogram divided by the distance is 17 meters. So divided by 17. That comes out even to 1.8235. 8235. Yeah, there we go. And then, oh, wait, hold on. There's a minus sign, so that minus sign is there. And so this ends up being negative. So negative 1.8235 newtons per kilogram, okay? So the change in potential was positive, but there's a minus sign outside of it, and that's what that minus sign is there. Right, the 17 meters is positive because we went up 17 meters, right? But that makes the gravitational negative, right? Which, of course, I guess they always come out negative if you do that, right? Okay, so let's see. So what is the gravitational field strength? It's 1.82 whatever. Does it point toward A or B? Well, it's going to point toward A, right? Okay, because it's going to be this way. Which point is at higher elevation, A or B? Well, if it's pointing toward A, then B must be higher, right? Yeah. All right. Wow. Is that it? Is that all we had to do? It didn't do. We didn't ask for a force. What way would the force be on some mass? Anyway, yeah. If they asked that, you'd just use this G as F over M. This is a one-stepper. That's crazy.